First, we are given the L equals to 2.0 meter, and the current I is equals to 8.2 ampere. In the first case, we have the wire lie on the positive x-axis. This is a positive x-axis. So we assume the current going this way. This is the I. Now, this we know F is equals to BIL, and the direction of this F is given in the y component, and we know the direction of current is in the positive x. So the B must be in the z component because this FB and this L must be perpendicular to each other. So we can solve for this BZ. This is negative 0.1524 Tesla. And in this case, you can see this F only have the y component. Actually, that means the By will equals to 0. Otherwise, the x will have more than the y component. Now consider the second case. This is lie along the positive y. So the current will go like this. In this case, we are going to apply this FB will equals to the IL cross B. This is equals to I is 8.2, and behind here is just a cross product. So X, Y, and Z. Now for this wire, we only have the Y component, so 0, 2.0. The Z is 0. Now B field, we do know the Bx, we know the By is equal to 0, and the Bz is given by this value. Oh, by the way, this should be the positive. The reason is that if you use the this left hand rule, like this is the x and this is the y and this is the z, you can see here, if you use the left hand rule, you can see here our force, the direction of this force is given by here, right? Negative y, so given like this, and this is our x. This is the direction of the current in the first case, and to produce this thing using your left hand, we must have this magnetic field in the positive z component. So remember this L cross this B, right? So to get this is positive, we must have this thing L cross B. So we get this is the negative y for the force Fy. So in this case, this Bz must be the positive 0.1524. Now we solve for the cross product here. This is 2 multiplied with this value. Yeah, this is 0.304. for 8x, and y we have the 0 multiply with and 0 multiply with is 0.1524. So we have a negative 0 in y component, and finally the z component. The z component here you can see 0 multiplied with 0 will get the 0, and minus the bx multiplied with 2.0. So this is a negative 2.0 bx in the z component. So this is 2.5x and negative 16.4z. Now actually this the force is given, which 2.5x negative 5.0 z. So we compare this z component here. Sorry, here we have bx. We compare these two, so we get a 5.0 equals to 16.4 bx. So the bx equals to 0.305 Tesla. Now we rewrite this b in the vector form. We have the x component will be 0.305 x, and we have the z component plus 0.1524 z, and the unit being Tesla. So this is the answer for this question.